Have you ever wondered how video games create such realistic worlds with detailed characters, lifelike lighting, and smooth animation? Or how animated movies manage to show sparkling oceans, glowing fire, or soft shadows that move with the sun? Behind all these visual effects is a special kind of program running on your computer's graphics card. These programs are called shaders. Shaders are the hidden artists of computer graphics. They control how objects are shaped, how surfaces look, and how every pixel gets its color. Whether you're playing a game, watching a 3D animation, or using an app with fancy visual effects, shaders are working in the background to turn data into stunning images. But what exactly are shaders, and how do they work? Shaders are small programs that run on the graphics card, also known as the GPU. They are a key part of how modern computers create images, especially in 3D graphics. These programs tell the GPU how to draw each part of a scene, from the position of objects to the color of each pixel on the screen. Shaders are used to control the entire process of turning 3D models into a final 2D image that you see. They can control how objects are shaped, how surfaces reflect light, how textures are applied, and how special effects like fog, fire, or water appear. Because the GPU is designed to handle many operations at once, shaders are written to run in parallel. That means they can work on thousands of points or pixels at the same time, which makes them very fast and efficient for graphics processing. There are different types of shaders, each with a specific role in this process. Two of the most important types are vertex shaders and fragment shaders. A vertex shader is the first step in the graphics pipeline. It works with individual points that make up the shape of a 3D object. These points are called vertices, and they define things like the corners of triangles that form the surface of a model. The vertex shader takes each vertex and applies transformations to it. This includes moving the object to the correct position in the 3D world, rotating it, scaling it, and finally converting it into a 2D position on the screen. The vertex shader can also calculate and pass along extra information like color or texture coordinates, which will be used later when determining how the object looks. Once all the vertices are processed and the shapes are ready to be drawn, the next important step is the fragment shader. A fragment shader runs for every pixel that will be drawn on the screen. It takes information from the vertex shader and uses it to figure out the final color of each pixel. For example, it might look at a texture image to find the right color, apply lighting effects based on how light hits the surface, or add shadows and highlights to make the object look more realistic. The fragment shader is where the detailed appearance of objects is created. In summary, shaders are powerful tools that let developers control exactly how things are drawn on the screen. The vertex shader takes care of the shape and position of objects, while the fragment shader handles the color and surface details. Together, they form the foundation of real-time graphics in games, simulations, and other visual applications. Without shaders, modern visual experiences simply wouldn't be possible.